Okay, welcome everyone. I hope you're all well, and thank you for joining us on this week's webinar, which is part of our ongoing PLM modernization series. If you did miss the first two episodes of the series, then you can always head over to our website where you can watch those on demand. Today, though, I'm going to be expanding a little bit more on last week's, 2 weeks ago, our last episode where we looked at the CAD-centric model compared to the part-centric model. And my aim for this week is really to hopefully paint more of a realistic picture of how you can leverage those tools and processes that we talked about and apply them more to a slightly more real world situation and put them into perspective for you. So without further ado, let's get cracking. So a little bit of an agenda. I do a little bit of a refresher on last week. Deepan, my colleague, covered quite a bit in that. So just highlight a few key aspects that we ran through. Going to talk a little bit more about part classification and why that's important. We're going to take a look at some approaches to the bill of materials when we talk about top-down design and we talk about bottom-up design. I've then got a demo that hopefully should tie all of this sort of stuff into a slightly more real-world example for you all. We'll then wrap up covering up what we covered in the demo, that sort of stuff, and then we've got hopefully some time for some Q&A at the end. So if you do have a question, please use the built-in chat functionality within GoToWebinar. A little bit about me. My name is Rory Allen Bocart. I'm a customer success manager here at PDS Vision. I've been here over a decade now, and it's my job really to hopefully give you, our customers, all the information you require to make informed decisions based upon our the tools and the offerings we provide as a business. So for those that maybe aren't aware and you're joining this webinar for the first time, PDS Vision, we're a global business. We span over 16 different locations across the globe. We have over 500 employees, which is constantly growing, and over 300 of those are technical experts and are hands-on with the tools and offerings that we sell and offer. So our expertise encompasses the entire PTC portfolio, along with all the ANSYS technology and simulation technology there, as well as our own range of applications and IP, which is branded under the MyPDS application suite. And these tools are designed to add even more value to the investments, whether that could be CAD, PLM, ALM, SLM, IoT, and AR. And our HQ is in Stockholm. So in the first episode, I talked very briefly about the digital thread. And I just want to come back to that and just refresh you all on what the digital thread means to us and where we currently sit within this digital thread in this presentation today. So the digital thread is really the seamless flow of data across an entire product lifecycle. Okay, and the idea of that is it connects people, it connects processes, and it connects systems right from the initial design of a product, through to manufacturing, servicing, and beyond, really. And it ensures that everyone along that journey, whether that's engineering, they're on the shop floor, out on the field, or in purchasing, wherever it may be within the business, they have access to the data they need at the right time when they need it. Okay, and that enables better collaboration, it enables the business to make faster decisions, and it ultimately increases the efficiency of a product lifecycle. Today, though, we're looking at PLM, and PLM, in our view, in our digital thread within the sort of PTC universe, is really at the backbone of it all, and that's the product we're sort of focusing on in this modernization series. And PLM is sort of the card holder that ties all of these other aspects together, and that is what we're focusing on. So a little recap then of what we covered in the last session. So we talked about moving towards a part-centric model rather than a CAD-centric bill of materials. How can we focus on parts rather than the CAD design? And in doing that, when we move to a part-centric models, it broadens the scope of our bill of materials. We can start to include things that branch out beyond CAD, things like consumables to glue, paint, but we could also include other aspects like software or documentation within our engineering bill of materials. It could even be ECAD or something like that. Okay, so and the idea being, if something goes into defining your product, it should be there accurate in your bill of material, in your engineering bill of materials. Okay, and leveraging a system like Windchill to do so also means we can improve compliance, we can improve traceability, data governance, and all the good stuff that goes along with it. So some of the key concepts that we covered then, we talked about the creation of these WT parts, okay, how we can derive those from the CAD data. We talked about how we can import information from Excel spreadsheets and define structures using those sort of third-party tools. Deepan also talked about reporting at a high level of how we can extract information from our BOMs. A couple of different approaches with manually creating part structures and the automated process of creating those structures as well, either from the CAD or again from importing Excel documents, that sort of stuff. Deepan also briefly talked about part classification, a topic which I'm going to dive into a little bit more detail today on, as well as touching on change management and maybe effectivity. But that's a whole topic in itself that we're going to cover in a future episode. So I'm not going to spend too much time on that. But all of these, ultimately sort of come down to, being able to generate more accurate and more accountable bill of materials, as well as doing that faster, reducing the number of errors that may be introduced through manual intervention. If we can automate that, we can eliminate some of that. And we have a stronger integration with downstream processes once we have an accurate and trustworthy bill of materials. So I just wanted to talk about the WT part again, just to inform you all and refresh you all, and for those of you that may be joining for the first time, just to give you an idea, because again, it is the backbone of it all. So the WT part, it's an object within Windchill, and it's basically like a reference card, and it holds all the information that describes that component. And the WT part represents maybe the manufactured item that your business produces. So underneath that, we have our component, our drill 400, and then that WT part references everything that describes it. Okay, so we've got the CAD to describe the form, fit, function. We've got the 2D drawing potentially that describes how the part should be manufactured. We might have some requirements, viewables, but that collector, that WT part, represents the part we're going to manufacture, and it is described by all of the other information that we put into the system. Those parts can then also be arranged into structures, product structures, from which we can then derive a bill of materials, okay, for various different parts of the business. So at the end of the last episode then, Deepan talked about a bit of a strategy of how you can approach the implementation of a part-centric system. And we're going to focus on the first three here. So defining a classification system and why that's important. Going to have a look at some of the BOM approaches and how we can approach a bill of materials, both with sort of top-down and a bottom-up approach, or a dual strategy, which is something that we tend to suggest. So let's start with classification then. So when transitioning to a part-centric bill of materials in Windchill, part classification plays a real critical role in ensuring that our bill of materials are structured efficiently, they're easily searchable, and they align with any downstream processes within our system. So one of the most important aspects of a bill of materials is that of trust, right? You've got to make sure that you trust the information that's in your bill of materials. Alongside that is obviously the quality of the data in that bill of materials. You're going to make sure, is that up to standards? If it's not, you can't really use it downstream because you don't know it's right. And part classification plays a really key role in that. And it's one of those tools that we have that in order to achieve an accurate and reliable bill of materials. And what part classification means is about taking those parts within a system and assigning them attributes or metadata that define them or categorize them in some way, shape, or form, and enable you to go, users to go in and find that information quickly. So without classification, a user could struggle to find something. If we took a CAD engineer, for example, they wanted to put something into one of their designs. They didn't know the part name or part number. How are they going to find that information within the system that may already exist? Using classification and this logical structuring, it enables users to go in and find that information. And PDS Vision actually did a survey with some of their customers, and we found, talking to our customers, we found that introductions of new parts can cost anywhere from sort of 500 up to £3,000 per part. So having your design engineers remodel and create duplication of products within your business can be quite a costly endeavor, and part classification is one of the tools that we can leverage to aid that. So how can we classify our parts? So as Deepan highlighted in the last webinar, we can leverage out-of-the-box Windchill attributes to help designate and classify our parts. Or our preferred method would be to leverage something like Windchill's parts link or part classification within Windchill. The reason being, this allows you a much more granular level of control over the attributes in which you assign to your parts. And then you can then group these items together based on function and their size, shape, material type, those sorts of things. Parts link also comes with quite a nice user interface for exploring and finding those items within the system, something that I'm going to show you in a demonstration later on. So once we've classified the components, then we then have to approach our bill of material in a particular way. And there are two classic methods of approaching a bill of materials. The first then is a bottom-up approach. This is where we start with the CAD structure, the CAD design, and push that information up into a part structure. Okay. Some advantages of this, it's quite a flexible way of working. It gives your design engineers a lot of control of how they want to construct the products. It allows for a little bit of innovation, potential for better part reuse as well. Engineers can go in and find existing components that fit the bill. And typically, this can be a faster way to develop a product structure. Not wholly, but typically we can see that. The other approach then is a top-down approach, okay? And this allows the business to define the part structure first, from which we can then derive a CAD structure. Okay, so we push that information down towards the CAD, so we start at the top level. Some advantages of a top-down approach: you get a nice clear vision, okay? It gives good visibility to everyone working on the product of how this thing should be structured. You can potentially reduce some risks by starting off with that structure early on and making that visible. You can potentially avoid some costly design changes potentially. And it also allows for a better collaboration, having that structure there early, everyone can see it. You can collaborate a little bit easier on that. So if you are working in sort of those strict terms, bottom up or top down, that's sort of the workflow that you'd be following. We tend to suggest, though, we often find that if you try and run with a strict policy on bottom up or top down, it reduces the agility of a business really. And Windchill is a powerful enough tool that you can leverage both of those approaches at the same time. So you can run with what we call like a dual bomb approach, where we do a bit of top down and a bit of bottom up, depending on where the business needs to work and how free that operation needs to be. So in a dual approach, the process may look something like this, where we have a principal engineer or a product owner maybe of a product that goes in and defines the overarching structure to outlay to the business how this product should look, but allow some flexibility and agility for the design engineers to fill in the gaps. So once we've defined that structure, we then may have a design engineer go away, work on the clutch, and then define the lower level structures of that product. Same here for the engine, where we offload a lot of that work to the design engineer, and they can build in the missing pieces. So as you can see, with that top-down design approach, we can overlay a structure and then allow the wider business to fill in the gaps that are left between that. Okay, let's hop over then. So I've got a bit of a demonstration. What I really want to do is tie some of the topics we've covered in the last episode as well as this episode and wrap this into a bit of a workflow. And hopefully this should tie everything together for you and give you an idea of how you can leverage some of these tools and functionalities within Windchill. Obviously, this isn't a hard and fast rule. All businesses have their own challenges and quirks and need to work in their own way. But this should get you thinking about some of the tools and how they can be leveraged within the system. So what I've got here, I'm logged in as a user called Pat, and Pat is a product owner. And we have an existing product, which is an electric motor within the business. And Pat's decided that, based on, I don't know, market research, speaking to his customers, that a slightly more portable version of this motor is required. This could be a configuration, which is something we might talk about in a future episode. But for this example, maybe Pat doesn't quite know where this product's going to end up in the future. So we're going to generate a new product introduction here. So if we take a look at the existing structure of the existing pump within the business, we're going to talk through some of the design changes that Pat thinks we're going to need to make here. So we've got our existing pump on screen with the part structure on the left and then the visualization on the right here. So some of the changes, we're going to change the base plate. That's designed to stick onto something, not be portable. The electrical housing there, we've had a few issues with. It's not quite big enough to get all the electronics in. And then we also need a handle so this thing can be carried around. Now, with this new product, a lot of the parts within this product can be reused. So probably like 90% or something like that. So rather than starting from scratch, Pat's actually going to do a save as operation and take all the existing design and reuse the majority of it here. So taking the top level part here, I'm going to grab all the dependencies and lower level items. And let's just go through some of these design changes. So the base plate here that we're going to swap out, we can remove from the structure in a second. The electrical box needs to change. And we're also going to create a brand new part that doesn't exist within the system for the handle. Now, in this example, all of these items sit at this top level assembly. So actually, the only part we really need to do a save as of is this top level. Everything else can be reused or removed afterwards. So I'm going to grab the CAD data along with the WT part, and we're going to do a save as of both of those objects at the same time. Obviously, if one of those components sat within a sub-assembly, we'd have to do a rename and a save as of that sub-assembly as well. But thankfully, all of these components are sat at the top level. So we'll do a save as. We'll give these both the part and the CAD a new name. And housekeeping, just check that those items are going to the correct folder structure. Again, that could be predefined and automated within the system. In this case, it's not. The other items we're simply going to reuse. So after the save as operation, we now have our new product. Okay, you can see it's underscore portable, representing that it is the new product. We're now going to make some further changes to the BOM structure. So this idea of more of a top-down design approach. So if we take a look, we need to make some changes. So we have, I know there's already a portable base plate within the Windchill system, but I'm just going to allow the Dennis, our CAD author, to go in and assemble that in future. So I'm just going to remove that component from our structure. I'm refreshing the browser. You can see the visualization will update it alongside that. Again, in a similar situation, we have a slightly larger electrical housing that I can bring into the system. And I will do part of the work already here. So I'll go in and add the existing component back into this structure. So selecting the top level, I'll go and find the larger electrical housing and we'll assemble that into our product structure. So you can see we've added that in. If I just refresh the browser again, you can see we've added that component in, but it's not defined within the CAD model yet. So it's just sat there. But again, that's for Dennis, our CAD author, to go and do afterwards. We're just defining the structure at this stage. Next then, we need to add in a a handle. This isn't something that we've developed yet, so I'm going to go in and create the new part. So we'll give it a part number. I'm not too fussed on the number. You could again have this auto-generate based upon your system, but we're going to go in and define the part. Alongside that, I'm also going to define the CAD object. You can see there we've got the create CAD document checked, and I'm going to go in and define my CAD part as well. Again, with Windchill, we have the ability to author for most of the CAD vendors these days. In this case, I'm using Creo, so I'm going to generate the CAD component. Give it the same part number as the part, and a bit of housekeeping again will ensure that the CAD document goes in the CAD folder. Finally, then, just to show off some of the other capabilities, I can go in and add in another new part. In this case, it's going to be a software component. Maybe I'm going to update some of the software so it runs more efficiently in a portable motor. Maybe it runs a little bit underpowered just to help when you're moving this thing around. I don't know. Could be anything. But there you can see we've now started to add in these non-CAD components into this product structure. Finally, then, we've made changes to this structure. So I'm going to check this back into Windchill to save those changes. And what I'm going to do now is compare this part structure to the CAD structure using the BOM comparison tool here. And what this is going to enable me to do is visually see where the differences are in this structure. Obviously, we've gone in and made some changes to this, and those changes haven't necessarily ported through to the CAD design yet. So you can see where we've added in our electrical housing and our newly created handle for this pump. They're not represented in the CAD structure just yet. So what we're going to do is going to build those items and push that information down into the CAD model. The software component right at the top of the model tree, obviously we don't need to push down and we don't need to represent that in CAD. Finally, then, what I'm going to do, I'm just going to notify Dennis, our CAD author, to go in and make these changes within Creo. So I'm using the discussions capability within Windchill here, which is a little bit like a forum type thing that you can fire up on various different objects within Windchill. There are plenty of different ways of informing our CAD author, but I thought I'd just show something a bit different here with this discussions dialog box. So we'll attach Dennis, make sure he gets notified. You can also add attachments and links and things to help describe whatever it is, whatever topic of conversation you're striking up here. We'll now switch over to Dennis, our CAD author. And as a CAD author, Dennis tends to work within Creo. So within the built-in browser, we can navigate and explore Windchill just like Pat did through the Edge browser there. So on his home screen, Dennis has got this notification for the updating of the CAD from Pat. We could provide links to parts and particular information that might correspond to that message. But Dennis is pretty good at his job, so he knows exactly where to go and find all this information. So the first thing we're going to do is open up the new assembly that Pat has created. And as we've gone and made changes outside of Creo here, Dennis is presented with this View Changes dialog box, where we can visually see what changes to the structure have been made outside of Creo. So we can easily see down at the bottom, we've got a legend, and that's color coded, so we can correspond and find out what's happened to some components. So we've got 2 items that have been removed, and we've got some newly created or added components within the structure. As a design engineer, I get choice to accept these or reject them. Maybe if I think something's going to have a massive impact on my model, I might want to take a more manual approach at bringing that into the design, or have the design structure change, so we can make that choice there. But for now, everything, it looks good. So Dennis is going to crack on. So we have a couple of unplaced components, which was what we added at the part structure, which we'll come on to in a second. But the first thing we're going to do is just go in and add the base plate that we need to add for this portable version of the the pump. So finding the part number, we can browse Windchill and pull that object in and just assemble that with the default constraint there. So that's the first object. That's the first change. The next thing we're going to have a look at then is the handle. So we created the CAD object within Windchill, but obviously we haven't defined any geometry within that. So it would now be Dennis's task to go in and define that geometry. But this isn't a CAD demonstration. So just to save a bit of time, I'm actually going to copy some geometry from an existing component just to speed this bit up, because we don't need to see how Dennis models the handle. Once we've generated the geometry, we then need to define it within the assembly. So again, I could use classic constraint methods, but again, just to save a bit of time in the demonstration, I've set everything up so I can just use the default constraint. The electrical housing we did have already in the system, and something we added in at the part structure level. So all we need to do here is define that, where that sits and is located in our assembly. And to do that, I've got a couple of coordinate systems that we can line up. So our product is now starting to take shape. There is just one aspect that we need to finish off though, which is on this electrical housing. And this is an opportunity to show off some part classification and how a design engineer might leverage this. So need some bolts, but maybe Dennis doesn't, can't remember the part numbers of these bolts that is required for this housing. So we're going to use part classification to help us find what it is we require from within Windchill. So opening up the built-in browser again, we can head over to the search functionality and find the classification search. So we can classify both parts as well as documentation. So you might want to classify or attach metadata based on or a tag of a particular standard to your documentation. So you can then run a search against standards and find which documentation matches that standard. In Dennis's case, though, he's more interested in the mechanical components, and we're looking for a bolt. So using these tags, we can start narrowing down our existing data set within Windchill to find the part we are actually wanting for our model here. So we've narrowed down to a flange bolt. We now have a list of available components, and on the left-hand side, we then get some further information that we can start filtering and determining the part that we want in our model. So the key criteria for me here is length. So we now restricted this down to 3, and we can find that actually all 3 of these bolts dimensionally meet my purpose. Something that may determine my choice is material, but in my case, I'm not too fussed. What I might be interested in, though, is this sorting status. So within Windchill, we can allow maybe purchasing to come in and determine and provide information based upon manufacturer as well as supplier or vendor. Purchasing might have a preferred supplier based upon they pay on time and that sort of stuff, and we can build that information into this part classification. So Dennis can now make an informed decision on which part he should use within his model based upon the vendor information that's been provided. So adding that to our workspace, or Dennis adding that to his workspace, we can now go in and finish off our model and assemble those bolts within our design. So this bolt actually has a component interface, which means the constraints on the bolt have already been predefined. As Dennis only needs to now choose the assembly level constraints. So if that's something you've not seen before, I just thought it'd be worth mentioning. So Dennis has now finished all of the CAD work. So the only thing left to do now is check this back into the system. Once that's been done, then Dennis's work is now finished. And if we jump back to Pat's screen, we can now see that there's a new version of the CAD model as Dennis has gone and made some changes. And all of those changes have now propagated through for Pat to check over and maybe sign off and release, whatever it may be. Or Dennis could raise a promotion request and progress further. But hopefully that's given you a bit of an in-context idea of how we can start leveraging some of these tools and functionality that we've talked about. So if we have a look from Pat's perspective, we saw that as a product owner, he had the power to go in and define a new product and define a new product structure by leveraging the save as functionality, where we could reuse most of the components and make changes where necessary. We also saw Pat introduce some non-CAD elements into the bill of materials, like the software element that we saw, as well as leveraging BOM comparison tools to understand the differences between the part structure and the CAD structure. You can also use these BOM comparison tools to identify differences between versions of structures as well. So maybe you want to compare the as-release version to the current version of the product structure. You can leverage the similar sort of UI for investigating those changes. For Dennis, we got to see how Creo and Windchill work together to allow him to define, to work on those predefined part structures that Pat had put together for him. We we saw how he could navigate finding existing information within the Windchill system, as well as being able to leverage part classification to easily find components that maybe he would have previously maybe modeled himself if he didn't know how to find them within Windchill, okay, preventing rework and saving time on his behalf and the company's behalf. We also saw within that parts classification the link we have with purchasing and being able to provide vendor and manufacturing information within that UI as well, swaying his decision in which component he chose within the final design. So a little bit of a shorter session this week, but some of the key takeaways here are making sure that building an accurate and trustworthy BOM is a really important factor when it comes to working within a PLM tool, and leveraging tools like part classification ensure that your users are confident that the data is within the engineering bill of materials is accurate and trustworthy. Okay, we talked a little bit about and showed adopting an agile BOM strategy with a little bit of top down and a little bit of bottom up working in parallel, and hopefully that's you're starting to now get an understanding of the true power of PLM, and maybe advancing from a PDM system to more of a product lifecycle management system. So be sure to join us on the next episode in the series, where we're going to talk a little bit of configuration management to help with product complexity. If you've got lots of variations in your design, we're going to dive into a little bit more detail on those on the 12th of March. So make sure you get subscribed to that session. And finally, so thank you from me. I will have a quick look at and see if we have any questions. No, doesn't appear so. But if you do have any, feel free to pop them in the questions dialog before the end. And if any come through, I'll take those offline and distribute them all back out to yourselves. But thank you very much.